Today's session will be very interesting. Today we are going to talk about NLP, natural language processing. It is also known as text mining, but this whole field is known as NLP, natural language processing. Until now, we have used linear regression, logistic regression, decision trees, random forest, boosting. All these algorithms work only on numerical data. They do not work on non-numerical data. They do not work on non-numerical data. You cannot apply these techniques because these are mathematical techniques. Mathematical techniques, mathematics works on numbers only. On non-numerical data, you cannot apply any of these techniques because non-numerical data, text data, natural language data is very different. Language is very different. For example, if I give you this example, this vacuum cleaner sucks. This is one of the review for the vacuum cleaner. Is that a positive review or is that a negative review? Is it positive or is it negative?
Negative.
क्यों यार? Why do you buy a vacuum cleaner for? We buy the vacuum cleaner for cleaning only, right? So the review says this vacuum cleaner sucks very well. I'm pretty happy with it. Amazon delivered it on time. It consumes less power. I'm damn happy with it. That's the overall review. Is that a positive review or a negative review?
Positive.
पॉजिटिव है ना तो वैक्यूम
Positive.
क्लीनर को खरीदते इसीलिए ना यस सर नो
Good,
इफ
sir.
दिस स्टेटमेंट इसका कंप्लीशन ऐसा होता है दिस वैक्यूम क्लीनर सक्स हैश डॉलर स्टार एंड सो ऑन then we know that this is a negative review yes or no
Yes, sir.
if this is in the context of praising this vacuum cleaner sucks very well I'm very happy with it then this is a positive review that's the problem with the text the same text without changing anything in some context it ends up like a positive review. In some other context, it ends up like a negative review. Do you agree with that? In numerical data, there
Yes,
is no
sir.
context. -3 means -3 only. +3 means +3 only. No matter what is in the context, what is the surrounding. Whereas in text, depending on the context, the meaning of text changes. One of the review for a pizza restaurant is I never had such pizza. Not sure about future either. Some people are so sarcastic that it will be very difficult for us to find out whether they are talking positively or negatively. Has it ever happened to you? Somebody was so sarcastic that we couldn't even find out what they're saying. This is one of the movie review. No action, no drama, no comedy, no romance, just pure horror. This is one of the movie review. Tell me, is that a positive review or negative review? Let me tell you the movie name. That was Salman Khan's movie Radhe. Is that positive or negative?
Negative, sir.
Negative.
So definitely
Review.
negative. Depending on the movie, it changes, isn't it? If it is a horror movie, then it's a positive review for horror movie. Yes or no? What
Yes,
I'm trying to say is handling text data. Text data is unstructured. Everybody expresses their feeling in their own manner. Yes or no? If you're writing a review for vacuum cleaner, is there a rule that everybody have to write the same manner? If I'm asking you your age, everybody has to give in the same way, isn't it? Some people will say I'm 25 years old. Some people will say I'm 30 years old. Some people will say I'm 35 years old, isn't it? This format doesn't change no matter who is giving their age. But if I ask them to write a review for their product, does it change? Is there any structure or is it unstructured? People can write in their own manner. Think about it. The structure changes, isn't it? So text data is unstructured data. What is text mining? Making sense out of that text data. Data mining on the text input, exploratory data analysis on the text data. It is also known as natural language processing. You're processing the emotions language. Remember the variables that we handled until now. Region, east, west, north, south. Though it is non-numeric, but this is not text data. This is not natural language processing at all. These are known as categorical variables. Still, we handle them like just like numerical data only. Yes or no? We still handle them just like numerical data. Do you agree with that point? We convert them into region 1, region 2, region 3, region 4. Yes or no? We convert them into 1, 0, 0, 0, 1, 0, 0, like that. Then we still treat that as numerical data only. I'm not talking about this type of categorical data. This is not the text data that I'm talking about. Give me some examples of the text data that I'm talking about here. Tell me some of the sources of the text data. Give me some examples. Customer reviews, everybody. Give me some examples. Customer reviews where you have a complete statement, complete sentence. That is example of text data. Flipkart reviews, blog posts. That is text data, real natural language data. Any other examples? Customer comments. Some people write comments in some of the products. That is example of text data. These are real English sentences. What else? What else? Customer emails. Yes or no? Social media tweets. Yes or no? Facebook posts. social media comments. These are all the text sources. When I say text data, I'm not talking about this data. When you have this data, is it considered as text data or numeric data only? In future, if you see region variable, customer segment ABC, card type blue, green, red, are you going to consider them as text data, do natural language processing on them? Is it required to do natural language processing on region and each west, north, south? No, that's not required. What kind of treatment that you can do when you have this type of non-numeric data? Let us recap once again what kind of treatment you can do. You can do two things, either one hot encoding or label encoding. Feature engineering can be done on it. Okay. I'm talking about these type of data, customer emails, customer feedback, blog posts, tweets, Facebook posts, news articles, social media comments, customer verbatim analysis. Sometimes you scan the documents and then you try to get the text out of them. This is the text sources data that I'm talking about. Okay. So how does the data preparation work here? For numerical data, your data is very well structured. In numerical data, your data is very well structured. Let's say if I'm talking about customer number of loans, for customer one loans, customer two loans, customer three loans, for everybody, the loans will be mentioned here. It is very well structured data. Whereas text data is not that well structured. Most of the text data, customer one review, customer two review, customer three review, customer four review. It is no guaranteed. It is not guaranteed that. Anuradha, you have a question? Quick question. Okay. So if you have four reviews from four customers, it's not guaranteed that all of them will have the same structure, all of them will have the same length, all of them are starting with the same word. There is no such, there's no audio, is it? Can you hear me? Can you confirm that, everyone?
Now it's okay,
Yes,
sir.
yes,
Yes,
sir.
sir, it's audible. It's audible?
It's audible. It's audible.
Okay, let's continue. So, like the way you have numerical data very well arranged, there is no guarantee that text data will be arranged like that. Okay, there will be a lot of discrepancy. That's why it is known as unstructured data. Yeah. So when you are working with text data, the important point, this is the important point, all of you try to look at this. The important point is none of the machine learning algorithms work on the text data. No, machine learning algorithms don't work on the text data. What we do is there are two steps in text mining or natural language processing. What are the two steps? First, take the text documents data, convert them into numerical form. This itself is such a huge step, isn't it? Taking the text document data, converting it into numerical form. Once you convert text data into numerical data, machine learning algorithms can be applied on them, then you can get the good results. No matter where you go in this world, when you are handling the text data, you cannot run any of the machine learning algorithms on the text itself because machine learning doesn't work on non-numeric data. You are supposed to convert them into numerical data, then you can apply machine learning algorithms on it. Numerical data is very well structured. So the first step is giving structure to unstructured text data. That is the first step. This is structured form of numerical data, which is equivalent of the text data. Now I'm going to tell you how do you make sure that you create a numerical data which is equivalent to this text data, which contains all the information from this text data. First of all, how is it even possible to convert non-numerical values into numerical table? Let us look at the details of that. So in NLP terminology, there are few words that are used that we need to be very well aware of because in numerical data, until now, in numerical data, we have something called train data or overall data. Whatever data that you have, you tend to call it as overall data. You have rows, each row represents one value related to customer, you have columns. But when you come to the text data or in NLP terminology, the full data that you have here, the full data, all the data put together, if you have customer reviews or if you have emails or if you have tweets, if you have social media posts or comments, the overall data is known as corpus. If somebody says, this is my corpus, what does that mean? He's talking about the complete data. Corpus is the complete collection of all the data that somebody has. Generally, rows are the ones that we tend to use in numerical data. Here, there is no concept of row. Here, each element in this text data, each entity, each observation, each record is known as document. Document doesn't mean it's a literal Word document or notepad document. No. A document means one entity, one observation, one record in the corpus. A document is one record in the corpus. For example, I gave you the data of 5,000 reviews related to a restaurant. Tell me in this scenario, what is the corpus? What is one document there? What is corpus here? What is corpus? All the 5,000 reviews is the corpus. What is one document here? What is one document here? One review is one document. Yes or no? For example, if I gave you one Word document, in that I gave you 5,000 tweets. I gave you one document only. So tell me what is corpus here? What is corpus in this scenario? All the 5,000 tweets is the corpus. What is one document here? What is one document here?
One tweet.
One tweet is one document. So is it true that sometimes one document contains only one line? Sometimes one document is a couple of lines, a paragraph. Sometimes one document is maybe 3, 4 paragraphs put together. If there is a text document with 5,000 tweets, if I ask you how many documents are there, are you going to say there is only one Word document with 5,000 tweets in it? How many documents are there from the NLP point of view?
5,000.
There are 5,000 tweets. That means 5,000 documents are there. That's the terminology. Generally, document is the one that people tend to confuse. Literal meaning of document is Word document, but that's not the document that we are referring to. We are referring to one entity, one observation, one record. What are the packages that are used for handling the text data? There are two packages with very rich documentation and a lot of functions and sub functions available in them. One of them is NLTK, Natural Language Toolkit. The other one is SPACY. We're going to use both the packages for handling the text data. Installation is pretty straightforward. You write pip install NLTK. You write pip install SPACY. There is one specific note that you have to make here, side note. That is, when you do pip install NLTK, it will install the package, but it will install partially only. What you need to do is you have to write nltk.download all. Then this will install the full version. We require the full version to work with the text data. Okay. So nltk.download all. This is the side note that you have to make. Even after installation, you have to write this. That will install everything. As I told you, preparing the data is very important because the raw data will have a lot of slack in it, a lot of unnecessary information. What do you mean by a lot of unnecessary information? For example, if you see the words like a, and, the, this, is, was, that, are, you, we, these are known as stop words, the words that are everywhere. Let's say if you take a positive review, if you take a negative review, or if you take a sports document, sports article, if you take a politics article, news article, where do you think these words will mostly appear? Let us take positive versus negative review. These words will appear in positive review or they will appear in negative review? Where do you think they will appear? A, and, the, this, is, that, we, that, you, we, are. Where do you think they will appear? They'll appear positive as well as negative. Do you think they have their own meaning, or just for the sake of completion, to complete the sentence and the language, we need to use them? These are known as stop words. They are present everywhere. Do you agree with that? Do they really decide whether it is a positive review or negative review based on these words? Can you decide them? No, it's impossible. Are they really useful when you're doing, let's say, when you're doing document classification? Are these words really useful? They're not useful, isn't it? They are everywhere. In fact, if you keep them, the machine learning model will get confused. These words are appearing in positive reviews as well as these words are appearing in negative reviews. In fact, the machine learning model will have lesser accuracy if you have all these words. Now, in English language, you have present tense, past tense, future tense, simple, perfect. Like there are different ways of forming a sentence. Usually, when people are talking about NLP, mostly they talk about English language only because most of the documents, most of the data that we handle will be in English language only. Even in India also, if you go to even regional places, there also most of the documents will be in English language. So in English language, you have the same word buy, bought, buying. These three have three different spellings. Do you want the machine learning model to treat them as three different words, or all of them have the same meaning? Are these really three different words? Do you think the machine learning model has to treat them separately, or all of them mean the same thing? It simply means it's buy only. Somehow we need to convey this message to machine learning model that treat all of them the same way, though they have very huge difference in their spelling. But you must buy versus bought, completely different spelling. Only one letter matches, but still you want to treat them as the same word. Somehow we need to tell this to machine learning model. Few documents have date time values: 19 September or August 2022, 12, 52, PM. When you're doing positive versus negative sentiment, maybe these kind of numerical values, they not have any add any value. Especially when you're working with social media data, like Twitter data or Facebook data, you will have HTML links, you will have email addresses, you will have image file links. Are they really useful? HTML links, email addresses, maybe they may not really decide whether it is a positive document or negative document. That can be ignored. Special characters or punctuation, something like colon, semicolon, hyphen, those are the ones that they do not have add any value, because most of the things we keep it for the sake of completion of the sentence. Okay. Once we are working, or once we are looking at it from the analysis point of view, machine learning point of view, that may not be useful. Uppercase, lowercase, it doesn't matter. Spelling mistakes, correction, like a lot of times people write spelling mistakes. Somehow we need to correct them before doing the analysis. Yeah. Please go ahead, Soumya, with the question.
Sir, as we have the date time values in the reviews or blog anything.
Hmm.
So if the format of the date is, for example, DDMMYY,
Hmm.
and some of the date formats can be MMDDYY. So
Yes, it is even more
both will
challenging.
be
We have to find that and remove that, isn't it?
okay.
It
So
is
both of
challenging.
them are representing the same.
Same thing, but both of them are useless for us. Yes or no?
Yes, yes.
Think about, you are deciding in a review, एक ऐसा date है, in other review, एक ऐसा date है. Okay. Both the dates are not useful, isn't it? Tell me whether which one is a positive review, which one is a negative review based on the date format.
We can't
Does it
decide
matter?
anything.
Date format, does it
No,
matter? Does it have any impact on the polarity, positive or negative? No. So we have to identify
no.
these type of dates. These type of dates, simply remove them, no matter which format they are in. Irrelevant. Yes or no? That's
Yes,
what I'm
yes.
calling it as slack. What do you mean by slack? Unnecessary information. Cut the slack.
Unnecessary data.
Yeah, unnecessary. ये भी unnecessary है, ये भी unnecessary है. दोनों को cut कर दो. Okay. Remove it. Basically, keep only the gist, the final juice in the review, so that you can very easily find out whether it is a positive review or negative review. Okay, later on. Before analysis, we have to do this data pre-processing, especially when you're working with social media data, something like Facebook data, Twitter data. You will be facing a lot of such issues. At least I have listed only a few issues here. When you go to the real world, people working on the real data sets, they will see so many more issues than this. Do you agree with that? These are just a couple of examples that we
Yes,
discussed here, isn't it? We have to
yes,
identify
sir.
them, especially when you are on the social media data, because there are no rules there on social media. People can simply write anything or everything. Twitter data or the Facebook data or WhatsApp data, something like somewhere you got it from LinkedIn data. That is where you have to do a lot of pre-processing. Let us take one such data set and see what are the steps in pre-processing. Let us take a difficult data set, a Twitter data. This is one of the data set. Okay. Right now, what we are trying to do here is, the objective of this is, take this raw tweet, that is our text data. That is our text data. Okay. First of all, it is not a rule that you have to remove dates in every scenario. Remember, you have to understand the problem statement. If the problem statement is you want to do sentiment analysis, then it is irrelevant. Yes or no? If you feel date value is very important, you must keep it. Yes or no? If you feel
Yes,
email addresses are very important, you must keep them. If your analysis itself, your problem statement itself, find all the email addresses from the text and send them emails. If that is the point where you are starting, then we will not be deleting the email addresses. Yes or no? Depending
yes, sir.
on the context, you have to take the call, isn't it? I'm discussing this from the context of sentiment analysis, finally saying positive or negative, or maybe document classification, sports versus religion or versus politics, this type of classification of the documents. If you want to do, depending on the context, you have to take the right judgment. These are some of the things that we need to do depending on the context. What is the context here? Given the tweet, we want to find out whether it's a positive tweet or negative tweet. Right now, this is our data. As of now, you ignore this variable. Act as if you do not have access to this variable. This is our text data. This is our raw tweet. That is our raw data. We have nearly 27,000 tweets. Okay. What is our objective here? We want to pre-process this data. We want to pre-process the data. So there are certain steps. Let us go step by step. The first step is converting everything into lowercase. Okay. So before that, let us first open the code file. Let us get the data set. Once we have this data set, then we go to the data pre-processing steps. Okay. Let's go to the code file. If anyone has opened the code file, you can paste the link in the chat window so that everyone can click on it. and access it. A lot of links are pasted. I'm also taking from there only. This is the code file. NLTK, Spacey. Automatically, they are added to Google Colab. So if you're working on local systems, you can use this command. Otherwise, you can proceed. As I told you, NLTK.download all. That need to be done by you because pip install NLTK will install partially only. But here we are not anywhere running it because NLTK is already there. We are just executing these commands. Directly we are importing NLTK because NLTK is there and we are downloading the rest of the ones. And this will take a couple of minutes for installation. After that, import the data set, print a sample of 10 tweets. Once you have the Twitter data in front of you, send me a confirmation message. Don't go too far ahead. Just import the Twitter data. Once you have it in front of you, send me a message. Right? Before we proceed, let us take few questions, quick questions. Anybody? Honestly, we haven't discussed a lot. I just told you some of the rules. We are going to get started with the data pre-processing one by one, one by one. I'll tell you what are the pre-processing steps.
Sir, if we are working in a local machine, then we have to install pip
pip
install
install करके
NLTK
install
and
करना पड़ेगा
SciPy in the.
ऐसा इसमें ना ये कमेंट को निकाल के ये रन करना पड़ेगा ओके
Okay.
yeah these two commands
And NLTK dot download all, it is mandatory to be done.
after installation import NLTK
Yes.
कर दो इसके बाद ये कर दो ठीक है
Okay.
now the first step of pre-processing is there are some upper cases there are some lower cases convert everything into lowercase this code over here this function is known as apply function by any chance this apply function was it covered in Python was apply
Yes, sir.
function covered perfect but
Yes,
still
sir.
we will have a quick recap of that. So there is a raw tweet. I want to convert it into lowercase. How do I do that? So here is the syntax. I write the dataset name, Twitter underscore data, and whatever is the column name that you want to write. This is a new column. This doesn't matter. The important piece of code is go to the dataset, Twitter data, take the raw tweet, which is the column, raw tweet column. What is raw tweet? This is the one that I'm talking about. Go to this column and simply dot apply apply lambda lambda and then x colon. This is syntax. Dot apply lambda x. And whatever you want to do on x, you can write it here. Basically, you can write a for loop. Go to the first row, convert everything into lowercase. Go to the second row, converting everything into lowercase. Go to the third row, you can write a for loop, isn't it? For I equal to 0 to n. Do all these steps. You can write like that. But within one shot, you want to apply that lowercase on this whole column in one shot. How can you do that? You write dot apply lambda x, whatever function. Let us suppose if x contains some numerical values, -5, +5, -8, +8. If you want to convert them into absolute values, you write absolute function of x. So what will be the result? Your result will be x from, what does x represent here? Tell me, what does x represent? X represent every row here. Okay. So go to the raw weight, call x as every row and apply absolute value. But here, are we going to convert them into absolute values? No. What is our requirement here? What are we trying to do in this step? I want to convert every row into lowercase. Simply you write x dot lower. This is the function that will convert everything into lowercase. But unfortunately, some of the tweets have just numerical values. Somebody just wrote hash 2509 2026 or something like that. Somebody simply wrote like that. Numerical value. In this whole thing, it is not non-numeric or simply somebody wrote like this. Now, can we apply lowercase on this number? Does it work? Dot lower? On numerical values, it doesn't work. So what we do is we convert X into string. STR stands for string dot lower. To be on the safe side, try to write dot. Whenever you're applying any of the string-based functions, on the safe side, convert it into string. If it is already a string, no problem. If it is not a string, then it will be converted. Does it make sense, all of you? Does it make sense to you? Yeah. This is the code. And you save all this in a new column called tweet underscore lowercase. Okay. Is this code clear to everyone? Yeah. The important one is take the column name, dot apply lambda x. इसके बाद जो भी whatever you want to apply, that function need to be written here. This is known as lambda format or apply. If you have understood this logic, if you want to write, if you want to achieve the same thing using a different piece of code, that is also perfectly fine. In Python, every operation can be done in 2-3 different ways. Have you realized it? When you're doing your projects, have you realized the same thing can be done in 2-3 different ways? You can follow any approach. Okay. Over a period of time, when you keep on working on them, then you yourself will identify which one is the best way to apply for what type of function. So you just need to, in the beginning, you just try to get the output. Later on, you can achieve efficiency. That is the first step. The second step is tokenizing. What do you mean by tokenizing? Dividing the whole sentence into word tokens. What do you mean by that? Breaking the sentence into word tokens, dividing it into word tokens. That means if the example is my car is possessed, won't stop honking, what I want to do is I want to convert that into my first token, second token, third token, fourth token. I want to convert it into words. These are called as word tokens. Why this step is necessary? Some of the pre-processing steps that we are going to apply later on, they take the tokens as the input. They don't take the whole tweet or the whole sentence as input. They take these word tokens as input. So how do we work on that? Once again, tell me the structure. Twitter data, and then go to the column. What is the column name that we need to go right now? What's the column name that I need to take? Which column? Tweet underscore lowercase. Yes or no? And then dot apply lambda lambda x. After that, whatever is the function that you want to apply. What is the function? The function name is word underscore tokenize x. But to be on the safe side, do we write x directly, or to be on the safe side, what we need to write here in the place of x? String value of x. Why that is necessary? Maybe if there are some numerical data, maybe this word tokenize may not work on it. So string value. So what is the output of that you will get? The output is my car is possessed. I want, like, basically this is the input. This will be the output. This is the input. This will be the output. Okay. Let us do these two steps. Go back to the code file. Don't go far ahead. Simply execute the first step, which is converting everything into lowercase. Looking at an example of sample 10 tweets and then tokenizing. These are not that hard to understand, isn't it? These are simple steps. The real steps are coming up. This is not really a very, very useful pre-processing, but this is good pre-processing nonetheless, but they are not going to have huge difference in your output or the results. The actual pre-processing steps are coming up. Okay.
So what is the means of tokenization?
What is the meaning or the need?
Of tokenization?
Tokenizing means right now there is only one sentence, right? This whole thing is one sentence, one string. Dividing it into smaller sentence. If you see this here, this whole thing is one string. We converted that into 1, 2, 3, 4, 5, 6, 7, 8, 9 strings. Okay, like that. Later on in the pre-processing,
Okay, sir.
let us suppose you want to remove these exclamatory marks. Okay. In the pre-processing step, exclamatory marks need to be removed. Once you convert into tokens, happy is one token, mothers is one token, day is one token. These are the two tokens. Now, out of these 1, 2, 3, 4, 5 tokens, how many tokens will be left after pre-processing? These two tokens will be ignored. Yes or no?
3.
Yes.
Only 3 will be left. So later on, we are going to do that. To prepare that, we are doing this token. Okay. Does that make sense?
Okay.
Let's say later on, when you are removing the numbers, this particular one will vanish. The remaining ones will stay. Okay. The next step is expanding the short forms. When you are working with non-numerical data, especially on social media data, a lot of people write the shortest forms or short forms. Ain't means am not. Can't means cannot. Couldn't have, could not have. For example, somebody wrote in a review, did not. Someone else in other review wrote, didn't. Do you want the machine learning model to treat these two as different words or they are same? Though their spelling is different, both of them are the same words. Do you agree with that? Somehow we need to take all these short forms, convert them into long forms so that everything is in the same structure. Do you agree with that point? Expanding the short form, because some people will be writing in this short form and some people will be writing in this expanded form. To bring uniformity, we have to convert these short forms into expanded forms. For that, we will use a function. We are defining this function. DEF means definition of a function. You are defining it expanded form. It's a simple function. What it does, right now I have created a whole dictionary. This is a complete dictionary where it contains short forms versus long forms. Actually, there are so many short forms. English is a huge language. Hundreds and hundreds of short forms are there, and then long forms are there. But what I have done is I have done some research. I have found out all the most widely used short forms in social media, and I tried creating this dictionary. So this is good enough to get started. But later on, you may have to add your own short forms and long forms, isn't it? For example, in your data, everybody is saying, you know, TC. That's what in your data everybody is saying that. So how do you convert that? What does the long form mean? TC means क्या है? Take care, है ना? अभी बहुत लोग lol lol लिखते हैं, right? Do we need to convert that also? LOL means what? Laughing out loud or something like that. Like if you feel there are some words that are very frequent, like you have to understand your data. Do you agree with that? You have to understand your data. In your data set, if you feel that there is one short form that is frequently used, if you feel that that need to be added to the dictionary, you can add that. But to start with, you can get started with contraction to expanded form dictionary. And then what are we doing? We are taking every token. We are taking every word from this tweet, and then we are checking whether it is form of this dictionary. If it is part of the dictionary, we are returning the long form. If it is expanded form, if it is not part of that, we are simply returning the word. That's what this function is doing. It will take every word, it will go through this dictionary. If it is part of this dictionary, then it will return the expanded form. Otherwise, it will return simply the word itself. So for example, if you give this sentence, it's under honeymoon by the good life. It's has been found in this dictionary, it will be converted to it is. Okay. Remaining words are not found in the dictionary, they are given as it is. This is just an example. But if you do that, if you run that on the whole data, it will look like this. So you can observe there are some places where I am has been converted to I am. Okay. Or something like maybe you can look for some other examples. If you run this sample again, you'll find again I am. So whatever we have given in this dictionary, the short forms will be like, if you re-execute this again, another sample will be printed. Then you can see like this mamas has not been converted. Why this not has been converted? Can you tell me the reason? Because it is not part of our dictionary. So obviously we cannot have a dictionary. It's impossible to prepare a dictionary that will cover every case in English. So this is good enough dictionary to handle the social media data. If you feel this dictionary need to be updated, then we have to update it with more and more words and their long forms. Okay. That is the code for converting the short forms to long forms. Until now, whatever pre-processing steps that we have done, they may not have impact, but the upcoming steps will have a lot of impact. Let us see the code for it. So look at this. The list comprehension, by any chance, was it covered in Python coding? List comprehension, was it covered by any chance in Python coding? List comprehension cover hua tha kya? Have you heard of it, anybody? No. Okay. Let us look at this. So right now, Twitter data, I'll go to the tweet lowercase, dot apply lambda x, dot apply lambda x. Here I have to put the function, right? So this is known as list comprehension. How do you read this list comprehension? Result, condition 1, condition 2, condition 3, condition 4, you keep on writing like this. So my result is expanded form of t. This is my result. Expanded form of t means what? It will go to this function, it will send it. Okay. For t in the tweet. So what this is doing, for every word in the tweet, it will take one word each and it will result in what? What will be the result? This is result. This is condition 1, condition 2, condition 3. So here we have only one condition for every t. So you have to read it this way. This is the first one. The first one is the result. Result is expanded form. This is second one is a condition. What is the second condition here? For t in the whole tweet. So we are splitting this tweet and then we are sending one word and we are getting the expanded form of it. And what is it doing? It is simply taking the tweet word and then going to this contraction to expanded form. If it is finding the word, it is converting it. This was not found, given as it is, given as it is. So that's what this is doing. So a list comprehension means it will be written in this list format, and then the first one will be result, and the conditions you will write one by one, one by one, one by one. Okay, this is the output. So some of the examples that you can see is don't has been converted to do not. Even if you skip this step, that is perfectly fine. Even if you skip some of the previous steps, lowercase, uppercase, that is also fine. But the next step is an important step. Especially it will have a huge impact on the final machine learning model. What is the next step? Stop words, identification, and removal. What do you mean by stop words? The words that appear in every document, whether it is a positive document, whether it is a negative document, whether it is a sports article or any other document, whether it's a legal document or anywhere, everywhere they appear. A and the, this, is, was, for, or. Everybody give me an example of two stop words. Everybody think of two stop words, a couple of stop words, a couple of them. Two stop words.
Was are.
On.
Was, or. What do you mean by stop word? Stop word means a word that appears almost in every document, but as it is, the word doesn't have a lot of meaning to it. Yeah, give me
Are.
some other examples. Yes.
Are.
And is a stop word.
Are. Am.
Are, am, but is a stop word.
hence,
Hence is a stop word.
still,
They,
till,
they, them, still,
Oh,
so. बहुत सारा है ना stop words. Yes or
yes,
no?
sir.
बहुत सारा होगा. Stop words, they themselves do not have the meaning. Any other have, had, मतलब like had ही है ना भाई विवेक. Had, what else? Yes, is S is a stop word? Yeah, maybe. मतलब इधर हमारा कोर्स में yes तो stop word होगा. In our chat window, yes, no will be the stop words, isn't it? A lot of people will say yes, a lot of people, some people will say no. Yeah. So these stop words, they do not have their meaning on their own. What we need to do is we need to identify these stop words and we have to remove them. Okay. NLTK package has given a list of 179 stop words. Into, is, it, most, of, own, over, the, their, them, themselves, to, under. These are all the stop words. Spacey has given 326 stop words. What these packages do, they have taken millions and millions of Wikipedia pages, millions and millions of Google News pages, and then they have scanned through them and they found the most frequent words. What do you mean by stop words? The words that appear in the most frequent manner. They appear in almost every document. So how do you remove these stop words? Here is the process. You take all the word tokens. Look at this carefully. You take all the word tokens, dot apply lambda. Take the word tokens, dot apply lambda x. Now look at this. This is list comprehension. Can somebody explain me what is the first thing called?
output.
Output or result. Then condition 1, condition 2, condition 3 and all that. The result is t. For t in x. What is x? If t is not in spaces stoppers, what is x? X is one row because that x is coming from here. Dot apply x. Yes or no? Dot apply x for t in x. If x is not in spaces stoppers, is it clear? Look at this, all of you. T, don't read it this way. T for t, in x if t, not in spaces stoppers. Does it work that way? Is that the way we should read? T for t. ऐसे पढ़ना है क्या हमको? Oh, ऐसे कैसे पढ़ना है? It's like result. Result हो गया. ये तो t result. What is condition 1? Tell me what is the next statement? How should we read it? Condition 1. कैसे पढ़े इसको? What is condition 1? For t in x if t. Is that next thing that I am going to read? For t in x if t. ऐसा पढ़ना है क्या? नहीं. What is the next thing? For t in x. X is what? X is tweet here. Or here it is word token, one word token. For every word token, if it is not in spaces stopwords, just keep that. If it is in spaces stopwords, ignore that. I will be ignored, isn't it? How will be ignored? I will be ignored. Am will be ignored. These things will be ignored. Do you agree with that? Because they are in spaces stopwords. Spaces stopwords will be ignored. When you apply this code, the result will look somewhat like this. Off will be ignored. To will be ignored. So will be ignored. Should be will be ignored. And I have to will be ignored. Remember, whenever you are applying any pre-processing step, you have to be clear in your mind what is your end goal. My end goal here is doing document classification or sentiment analysis. From that point of view, these stopwords are not useful for me. If you keep these stopwords, machine learning model will get confused. What will happen? In the positive review also, these words will appear. In the negative review also, these words will appear. Then the machine learning model will think that the patterns are almost same. It will have lesser accuracy. If you remove these, in positive reviews, only certain type of words will appear. In negative reviews, certain types of words will appear. Machine learning model will get good benefit out of it. Are you with me, everyone? Why we are removing stop words? Are you convinced with that logic? These stop words are not useful from the analysis point of view. Maybe if you remove stop word, this sentence may not be good for reading. But are we going to read this sentence? What are we going to use this sentence for? Are we going to publish this sentence? Are we going to put it somewhere? No. We are going to use it for analysis. From analysis point of view, even it's fine. For model building, it's not really required to make grammatical sense. We just need to keep the real gist, keep the meaning out of it. Are you getting it, everyone? Though it is not making any sense even after removing these stoppers, but we want to use it for model building, it is perfectly fine. Apart from these stoppers, if you feel there are some additional stoppers, these are the generic stoppers. Based on your data, there will be some additional stoppers. Do you agree with that? Let us suppose if you are working on iPhone reviews. Look at this, all of you. If you are working on iPhone reviews, there will be some specific stoppers to only those iPhone reviews. Do you agree with that? In iPhone reviews, the stoppers, what will be the stoppers? You have taken
Maybe
10,000
iPhone
iPhone
will appear.
reviews. Hmm?
iPhone can be one stopper because
iPhone
iPhone will
itself
appear
will
in
be a
multiple
stopper.
lines.
Everybody will say iPhone, phone, बोल रहे हैं, right? Apple, can it be
Phone,
a stopper?
mobile,
Apple is a
Apple,
stopword.
mobile,
Mobile is a stopword, right? 13 भी stopword होगा. मतलब नंबर तो निकाल ही देंगे.
14,
14 भी
15.
stopword होगा ना. 15 ये सब चल रहा है आजकल. Yes sir. Pro भी stopword होगा ना. Pro. Usually pro
Pro.
is a good word, isn't it?
Max.
Max भी stopword होगा. Do you agree with that? Only these are the stopwords in this context. But are we going to remove them from Twitter data? Does it make sense to remove pro from Twitter data here? Generic Twitter data? No, pro is a good word. You should keep that. Yeah. But when you're talking about iPhone data, these will be the stoppers. Maybe when you're working with Twitter data, sometimes you will see RT, retweet. Now that will be a stopper. That can be removed, isn't it? Like, lol, need, do, these kind of stoppers can be removed. So what you can do is you can update. What you can do is spaces stoppers dot update. You can update with few words. Or if you think you want to keep some words, let us suppose these negations. If you look at this, and or didn't, I don't want to consider them as stoppwords. I want to keep these. Maybe they will help me in doing the sentiment analysis later on. If I want to keep them out of 326, I would like to consider only 320 as stoppers. Or I would like to consider only 315 or 310 only as stoppers. Remaining 16 words, I want to keep them. I don't want to consider them as stoppwords and remove them. That is also possible. All that you need to do is you try to update. You try to update stoppwords dot update. Let's say 326 stoppwords are there. Maybe out of 326, only 310 I want to consider them as stoppwords. Plus these 5 or 6 stoppwords, overall 316 can be considered as the final stoppwords. Possible. There's no rule that you have to follow the stoppwords dictionary given by the spacey and you have to remove every stopper. You can always customize it. And customizing is important for a given data set, isn't it? Let's go back to the code once again and try to remove the stoppwords. Look at this. NLTK stoppwords. Spacey stoppwords. Spacey has given a lot of stoppwords. Okay. Now what we try to do, this is one example of removal of the stoppwords, and these are the other examples. So let us see whether stoppwords were removed or not. This I has been removed. You can look at some of the examples. Maybe some other example if you want to see. If you just re-execute this, you will get another example of, so that I has been removed again. I has been removed. Some of the things I and all those things are removed. I'm not saying this is a perfect step like every stopword is removed, but to a great extent, a lot of slack will be removed. Again, if you want to do the custom stopwords, okay, then what do? You add these custom stoppers, you do the spacey stoppers, update the dictionary, and then you can further do this as well. This is called stopword removal. As I told you, the previous steps you may miss some of the previous steps, but this step you cannot miss. Stopword removal. All right. The next one is very, very important one. Sometimes you may have numerical values. You may have numerical values inside your text. You may have to identify them and you may have to remove them, or you may have to extract and keep it in a different file. Something like date value, 15 December 2022, something like time value. Sometimes you have currency symbols, dollars and pounds and rupees and all that. Sometimes you may have to remove the punctuation marks. Sometimes you have HTTP addresses, email addresses, other symbols. You need to identify and remove all of these. And these addresses, these numbers can be anywhere in the text. To handle all of them, you need to use something called regular expressions. Regular expressions. How does regular expressions work? You write regular expression dot substitute. Write down the pattern. Maybe write down the pattern for identifying an email address. Replace that with space. That means you are deleting the email address. The string. This is the input string. Write down the pattern. Every regular expression has a pattern to it. For example, to identify numerical values, numeric string, you can give this regular expression. To identify an image file in a tweet, whether there is an image file or not, how do you identify that? Using this regular. This is a code in itself. This is called regular expression code. These symbols, these words have some meaning to it. Email addresses can be detected like this. HTTP addresses can be detected like this anywhere in the text. Simply we detect that, we replace them with space so that we can delete. But if your job itself is to extract them, then you detect them, you try to flag that as yes, found one date found, or 1 year found, or one time found using regular expressions. You can do that. These regular expressions itself is a coding language. It is part of C++, Java, everywhere. If you are somebody who have to work on text data day in, day out, then you must learn regular expressions to identify the dates, or to identify the numbers, or the currency symbols, or the email addresses, or HTTP addresses. Otherwise, manually writing them and manually finding them will be very difficult task, because they can appear anywhere in the text. These are codes. Actually, this means something. Do you have any idea? Anybody in the classroom, have you ever worked with regular expression? Especially people who learned coding from the basics, their regular expressions will be taught actually. This in itself is a coding language. You don't really need to learn it. But if you are going to work on text data day in, day out, then it's a good idea. Maybe spending weekend on regular expressions, finding them would be good. Otherwise, as of now, you can search for regular expression. If you want to identify numbers, if you want to identify digits, just go to Google and search for what is the regular expression for identifying digits. For whole numbers, this is the one. For decimal numbers, this is the one. For alphanumeric, what is the regular expression for identifying emails? What is the regular expression for identifying URLs? What is the regular expression for identifying date format? Different formats. Somebody was saying, what if somebody writes DD, MM, YY format? Somebody writes YY format, MM format, then DD format, or somebody writes DD, MMM, and then YY format. You can write regular expression 1 for identifying these, regular expression 2 for identifying these, regular expression 3 for identifying this. Different type of regular expression can be written. They will very easily identify these numbers. Otherwise, it will be very difficult to identify certain patterns. Not only for this, let's say if you are working with bank account data, and everybody is writing a review. Everybody is mentioning my bank account number is this, my bank account number is this, my bank account number is there. Let's say something like cust XXXX 9962 XXXX 1236, like that. Then you have to write a regular expression that will capture this kind of pattern. Are you with me, everyone? So these are some meanings. Let's say this means start of the string, dollar means end of the string. There is one regular expression all of us use in SQL. बताओ कौन सा regular expression all of us we use? कौन सा regular expression है? Star. What does this regular expression mean? Star means select everything, all. If you want to select only digits, D and all that. So star B is a part of regular expression. Like star, there are other symbols as well. Dot means it's a wildcard. This means matches a specific one. The character, string. So regular expressions also, like at the rate variable and all that. Like you can also learn this, but based on the need. If there is a need for you, you can learn it. Otherwise, if there is no need, simply you can use a regular expression that I have given you here. This one will automatically identify and remove URLs. This one will identify punctuation and remove it, punctuation of type 2 and remove it, remove the digits, etc. So what this particular code will do is, it will take the full tweet as input, and then it will remove the punctuation, it will remove the numerical values. If you feel numbers are not important for you, then only you should delete. If you feel numbers are important, you should keep them. One of the most common one, especially when you're working with Twitter data, is a lot of people nowadays put the tweets with images. Have you observed it? A lot of tweets come with images. When you
Yes, sir.
download the data from Twitter, that image comes in this format, http.twitpic or something like that in the text file. So these kind of twitpic, these HTTP addresses need to be identified, and our algorithm or our code has automatically, we use this regular expression which has identified this and removed this. Is it okay to remove these HTTP addresses? Think about it. If somebody has put an image, somebody did not put an image, which one is a positive review, which one is a negative review? That has no real meaning, isn't it? This pattern is not going to help us. TwitPic or something, whether it starts with T or whether it has 4 in it or 5 in it, or this particular piece of text is not going to decide the sentiment. Do you agree with that? In one of this TwitPic 4T4, in the other TwitPic is 5Z6. Which one is positive? Which one is negative? Tell me. Is 4T4 positive or 5Z6 is positive? Does it matter? Does this pattern matter? Do you think I need to give this to machine learning model, or we need to simply remove this? Think about it. This pattern doesn't matter, right? That's why I'm removing it simply. But in some cases, finding this email address itself is a requirement. In some cases, finding that date itself is a requirement. Some cases, finding the numerical value is requirement. Then you can use this regular expression and make a small editing to that, and then find that, flag it whenever it is appearing. That is the code for the regular expressions, using regular expressions to remove further unnecessary email addresses and unnecessary punctuation. The next step is spelling correction. What is spelling correction? A lot of times when people are on unofficial or informal setup, we tend to write a lot of spelling mistakes, isn't it? Because we don't care. Look at this. What a great, amazing week and all that. But this one is a spelling mistake. This one is a spelling mistake. There is a particular package called text blob. What it does is it'll take the tweet and it'll try to look at the surrounding sentences. It'll try to make sense out of the sentence and try to predict, okay, this will be corrected to a different spelling. This will be corrected. This is how you can do the correction. But there is a problem with this text blob. Since it looks at the only surrounding, sometimes in the process of making the spelling correction, it changes the whole meaning of the sentence itself. First of all, when you are doing the spelling correction, you are assuming that the person is trying to write this only. Yes or no? You are assuming that the person is trying to write amazing only. Is that an assumption or not? Tell me. But what if the person is not even thinking to write this amazing? So sometimes these assumptions may change the context of the tweet itself. For example, let's say amazing has been converted, excited is also fine, data science is also fine, great has been also. But still people don't use this text block. A lot of people discourage it. When you're working on real data sets, spelling correction is not done. Can you tell me why spelling correction is not done? Can you tell me what is the wrong thing that text blob has done here? If you look at this, what has been converted to that? What has been converted to that? Now, is it really a spelling correction? There was an assumption made by text blob that this is a spelling correction. The person was trying to write that, but he has written what? Don't you think that's a dangerous assumption? Yes or no? That's the reason why spelling correction is not done in the real world. Okay. What I suggest you is if you are working with informal setup, something like social media data, Twitter data, Facebook data, then don't do spelling correction. When you are working with formal setup, where you expect people to write good spellings, maybe there you can apply it, but still a lot of people don't use it. So spelling correction, I'm giving you the code, but I'm also giving you one disclaimer that generally people don't use it. So coming back to our code, regular expressions can be used for removing email addresses, tweet pics and all that. Okay. You can have a look at some of the examples and observe that whether it has been really removed or not, the pictures and all that. Tweet pic has been removed. Then the spelling correction, though I'm giving you the code here, we are not applying spelling correction on our data set. Have you understood the logic why we are not applying spelling correction? Have you understood the real reason why we don't apply spelling correction? Yeah. Next, probably the last one and the most important step. It is known as lemmatization. What is lemmatization? In your data set, you have create, created, creating, create. Do you think a machine learning model has to treat them as 4 different words, or we would like to tell the machine learning model that these are all a single word only? English is a language that has present tense, past tense, future tense. Different type of tenses are there. That's why we have to write like this to give a style or to make the sentence complete. But from the machine learning point of view, do you think you have to treat them differently? No, this is single word only. Buy, bought, buying. Are these really 3 different words from the machine learning model point of view, or all of them mean the same thing? Think about it. From the machine learning model building point of view, they're all the same thing, isn't it? So how do you convert all of them into the same word or the root word format? You can use something called lemmatization. Converting every word, different forms into the same word is known as lemmatization. What does this lemmatization do? It simply takes the original text. Let's say I would responded going. This will be taken, and what will be the resultant word? I will be left as it is, would will be left as it is. Responded will be converted to respond, isn't it? Respond is the root word. Going will be converted to go. Responded will be converted to respond. Going will be converted to go. This may not make any sense when you read it, but are we really preparing this for reading and publishing? What are we doing here? We are preparing this data to send it to a machine learning model. So is it okay? Even if it is not making sense, even I will be gone. Wood will also be gone, isn't it? Since it is for model building, it is perfectly fine. So lemmatization, after lemmatization, your sentence may not make any grammatical sense, but that is perfectly fine. We are not publishing it. We are going to send it to a machine learning model. So living will be converted to live. Forecast will be converted to forecast. Stopped will be converted to stop. Gonna will be converted to go to. Stuffs will be converted to stuff. But I'm not saying that this will be 100% perfect, because English is a huge language. Every word has different forms of words. Sometimes it is OUGHT, sometimes it is ING, sometimes it is ER, sometimes it is ED. So whatever best lemmatization can do, it will do it. Still, some words will be left out. Have you observed it? Finished would have been ideally converted to finish, but still some words are left, because the reason is English is a huge language, millions and millions of words are there. So lemmatization will try to do the best possible job. That itself is time consuming, because so many words are there. For all these words, it has to go through this and find out what is the root form of it. Okay. So this particular step of lemmatization is actually a little bit time consuming also, because every word inside your tweet need to be taken, and it should be checked against the dictionary whether it has to be converted or not, and the right form need to be converted. Lemmatization, in simple word, it means converting everything into the root form. Lemmatization going to have a huge impact. Lemmatization is going to have a huge impact on your final result. Do you agree with that? Otherwise, machine learning model is going to treat the same words in different ways. Using lemmatization, we are going to convert everything into the same form. These are the pre-processing steps. During these steps, if you still feel there is something that is left out, you can do the final cleaning, you can do the stop words removal and all that. Finally, once you have done all these steps, then your pre-processing is done. That means you have kept the gist in the data. It is now ready for doing the analysis. Remember, we did not really start the analysis. For numerical data, do you remember the data pre-processing steps? You take all the categorical variables, look at the frequency table, data exploration, validation, followed by the data cleaning. Similarly, the steps in text data are different. These are the steps. Now it is ready for analysis. Right now, for me, lemmatization is still working, because it will take some time. Taking every word and converting it into their root form will be time consuming. Let it run in the background. Now the data is ready for analysis. Usually what I suggest is, do not directly jump onto the analysis. Before getting onto the analysis, get some idea on the data. You can create something called word cloud to get some idea on the data. Have you ever heard or seen a word cloud? What is a word cloud? Let's say if you are talking about the tweets. What is a word cloud? A word cloud means the word that is appearing maximum number of times, that will come in the larger font. The word that is second most discussed, that will come slightly lesser font. Okay. The words that are discussed even less number of times, they will come in slightly lesser font. For example, if you take yesterday's and today's Twitter, everybody is talking about India versus Australia match. A lot of people on Twitter are talking about that. Then it will come in the larger font. Some people are talking about Modi. Then it will come in the next font. Some people are talking about Rahul Gandhi. Then that will come in this way. Have you ever seen any word cloud where the word that appears maximum number of times, that will appear in larger font? The word that appears very less frequently, that will appear in lesser font. What is the use of it? By this, you will get to know the most frequently discussed topics. You will get to know the most frequently discussed topics. How do you do that? You get all the text, use a function called word cloud. You can use any color map, color settings, and then generate word cloud. Figure size and all that, those are optional matplotlib commands. This is the command that will generate the word cloud. What is the use of it? You have 27,000 tweets. Without going through all the tweets, you will be able to tell what are the top most discussed words. If I ask you, tell me what are the top 10 topics or top 10 words, you will be able to tell that by generating a word cloud. So how do you generate the word cloud? You go here to the code file, and then any further cleaning that can be done, and then create a word cloud. So all of you go to the creation of the word cloud and tell me what are the top 10 words or top 10 topics. Because by looking at the word cloud itself, you will be able to tell that. You don't need to really browse through 27,000 tweets. Automatically, you can tell me what are the top 10 words just by looking at the word cloud. Yeah. The words that appear most frequently, they will appear in the largest text. Look at that. A good, have a good day, good morning, good evening. यही होता है ना ट्विटर पे. And then work. Everybody will be cribbing about work. Have a good day, good day. Love, I would like to do that. I would love to do that. Time. I think these are in one context, isn't it? Time, work, good, day. ये सब बड़ा बड़ा दिख रहा है. Yes or no? After this, if we go to the next topic कौन सा है? After this, today भी ज़्यादा दिख रहा है. Today, want, miss, know, new, think. Yes or no? Look, These are the ones. So the purpose of word cloud is to give you an idea on what are the top 10 discussed topics. Are you really getting a feel of that by looking at the word cloud? Can you tell me what people are mostly talking about or not talking about? Are they really talking about a cricket match in this data set? Can you answer that question? Are they really talking about a cricket match? Are they really talking about iPhone? Is it iPhone review data, Samsung phone reviews data? Is it restaurant review data? No, isn't it? We are getting some idea by looking at the word cloud. Are you getting that idea? Like people are talking about good morning. This looks like general Twitter data. Word cloud, the purpose is to give you an idea on what are the most discussed words. In fact, every time you re-execute it, slightly rearrangement of the formatting will happen. The same words, same context, a different color, different orientation, it will be printed. Until you get a good orientation, you can keep on doing it. Good work day, love, new. I think you're also getting to see what I'm seeing here, all of you, isn't it? That is word cloud. In fact, you can also format that word cloud to fit it in a logo or something, but generally this word cloud is sufficient. Once you have the word cloud, you will get an idea on the data. Usually the steps that we have discussed until now, they are not done in step-by-step manner like the way that we have discussed. We want to understand every step. That's why we discuss like this. But usually you create one pre-processing function. It will be just simple one step, one pre-processing function. In that, you do the lowercase conversion, you do the splitting or the tokenization, then you do the contraction to expanded forms. Then also you add the regular expression stuff, stopword removal, lemmatization, everything you put it in one pre-processing function. What does this one pre-processing function do? Automatically it will take care of all the steps. So usually in the real world, you may not be doing all these steps one by one, one by one, one by one, like the way that we have discussed here. The optimal way or the efficient way to do that would be you create one pre-processing function, include everything inside that. And what you'll be doing, simply pre-processing, give the input data and whatever is the column that you want to actually pre-process. Here in our case, it is raw tweet. It will then process the whole data. We have prepared the data for analysis. Now it's time to convert our data into numerical format. Until now, the data is in text format. This is the important conclusion here. Convert the data into numerical format. The numerical format of the text data is known as DTM. DTM stands for document term matrix. DTM stands for document term matrix. This is the numerical equivalent of our text data. Let us suppose you have 3 reviews, 3 documents are there. Loved this place is 1 review, 2nd review, 3rd review, 3 documents. In a document term matrix, the rows are documents. We have 3 reviews, so there will be 3 documents. There are 3 documents, that means there are 3 rows. The rows are documents. The columns are the terms or the unique words. Loved this place at and all that. So this is the document term matrix. Documents are the rows and the unique words are the columns. Then what are these numbers? Tell us 1, 1, 1, 0, 0, 0, 0, 0, 0, 0. What are these numbers then?
Present or not?
This number is this particular word. How many times this is appearing in that document? Right now, this one is appearing once. This one is appearing twice. This one is appearing like that. The reason why the pre-processing is very important, here is the reason. For example, there is a word called create. There's a word called creating. There's a word called created. A lot of people ask me this question. If we are anyway convert everything into document or matrix, why do we need to do the pre-processing? Why can't we directly do this? Here is the reason. The document term matrix usually have a lot of zeros in it. It will have usually a lot of zeros. Let's say if you're working with 5,000 reviews, can you expect the same word love to be appearing in every review? In all the 5,000 reviews, does it appear? Is it possible? Very, very rare. Do you agree? The same word will appear always in all the 5,000 reviews. It will appear only at few places, isn't it? So remaining will be zeros. The matrix will have a lot of zeros in it. It is known as sparse matrix. Sparse means a lot of zeros are there. So there will be a lot of sparsity in the data. Already there is a lot of sparsity. 90% sparsity will be there. 90% zeros will be there. Now, if you do not clean it, then what will happen? Create will be one column. Created will be another column. Creating will be another column. It will be 1, 0, 0, 0, 1, 0, 0, 0, 1. Are you adding more data points? Or are you adding more sparsity? Tell me. Are you adding more data points or are you adding more sparsity by not doing this? If you are adding these 3 words, you are adding more sparsity. If you would have done lemmatization, then it will be create. This will also be create. This will also be create. What it will do is it will add some richness to your document term matrix. This will enter your machine learning model. This will give you a better result. That's the reason why data pre-processing is very important. You must do data pre-processing, all those steps that we have discussed, so that this matrix is rich with data. If this matrix is rich with data, this will enter as a data set for the machine learning model that will give you good results. Okay. So what is the code for creating this document term matrix? There is a direct function called count vectorizer. What it does is it will take every word in our corpus and it will find out how many times it is appearing in each document. It will prepare this matrix. And it is true that document term matrix will have so many zeros in it. And we are saying minimum underscore df equal to 5. What does this mean? If a word appears overall minimum 5 times in the whole corpus, if it appears minimum 5 times, then only we are considering that word. Otherwise, the remaining words we are simply ignoring. Ignore the remaining words. So what it does, simply take every word, find out how many times it is appearing in the document and create the document term matrix. Okay. So once again, the code is take the word that is appearing minimum 5 times to use this count vectorizer. Looks like there's a warning in future that we'll see later. So these are the words. If a word is appearing in this matrix, it means how many times minimum it has appeared? Able. Overall in the whole corpus in 27,000 tweets, minimum 5 times it has appeared. Since here the data is printing only first 5 rows, last 5 rows, it is natural that you will have so many zeros. There is a lot of sparsity in it. But definitely all these words that you see here, there are 3,471 words, distinct words that have appeared minimum to minimum 5 times overall. Document term matrix has 27,481 rows, those many tweets, and 3,471 columns, those many distinct words. That is the final result that we are looking for. So as we discussed, there are 2 steps in NLP model building. Step number 1 is converting non-numeric document data into numerical format. Is that done? What is the numerical format of the text data called? What is the numerical format of the text data called? What is this called? This is called DTM, document term matrix. We have the numbers now. We can then build the machine learning model on these numbers. This is a numerical equivalent. Preparing this itself is time consuming, isn't it? Because these numerical data has to represent your text data. It has to capture the gist of the text data. And once you have this numerical format, then you can build an ML model on top of it. That is upcoming. As of now, we are done with the document term matrix, which is a numerical equivalent. Though we discussed in depth, in detail like this, generally it is considered as a small step. You just do pre-processing, create the document term matrix, go for machine learning. But there are several steps, sub steps involved in that one step.